Today we're working on part two. Homework for part two is also due tonight. Test tomorrow. Okay, so I still don't want to show you my spreadsheet. Not that it's, super surprising. It looks pretty much identical to my mod 4 part 4 calculator, but let's talk about parts of part 1. And if you have any more questions, just let me know afterwards. So in part 1, they gave us this information up here where we had this sort of bracketed system, just like our tax rates, where the more people you recruit, the more you're paid. So, one thing I wanted to write down are some of the answers to, I think that's question 1, just so you can see the rest of the numbers and compare your numbers against those. So, if you're not getting one of those 5 numbers, there's good odds, something is amiss somewhere in your calculator. Might want to dive into that. I think most of the other questions in part 1 are fairly straightforward, but I did want to talk about a few things with the goal seek questions just to remind you of. So in one of the questions, I think it's question 3, it says like, what's the minimum number of ACRUs you need to meet some certain amount? I just want to point out, do not forget to round these answers. ACRUs are essentially people, and so we can only have a whole number, and you need to make sure you round in the correct direction. So for example, let's say you have you run GoalSeek finds 269.29 ACRUs to meet this $1,000 goal. Even though that's closer to 269, you have to round up to 270. So just be aware of that. And the reason why is if you round down, you're going to be like a few dollars short. So just wanted to point that out. You can also just test this amount. So after GoalSeek finds some fractional number in your ACRUs cell, just go ahead and test it. Type both numbers in that you aren't sure of which one's the correct answer. And like in this case, you'll see 270 is the first time that you make at least $1,000. Last thing I wanted to remind you of, when you get to part 2, question 5, and you're comparing two calculators and essentially trying to find an intersection point, that's also something that can be done with GoalSeek. You just need to set up one of those difference cells first, where you subtract the two payments from the two calculators you're comparing, and then GoalSeek is able to find where they're the same by goal-seeking that cell to 0. Okay, so that's the majority of the part 1 stuff I wanted to mention. If you've looked ahead to part 2, you've probably noticed most of the questions in part 2 are, well, not maybe most, but a lot of them are more just describing the situation and not actually computing anything or setting up a calculator. And I wanted to go over some of the definitions they introduce in this part of the workbook by going back to part 4 and describing what's going on here. So part 4 of module 4. In part 4 of module 4, we built this calculator here, and we had 2 different types of tax rates. We had the tax rates that were in each bracket, and then we also had this tax rate at the end, which was sort of like an average of all of them. And so when you're working on the homework for part 2, they're going to be talking about 2 different versions of this. They're going to be talking about an average number and a marginal number. And when they say marginal, they're talking about one of these guys, one of like the numbers you actually wrote down. So like one of those guys would be equivalent to like the marginal numbers. And when they're talking about average, they're talking about that guy. Now, it's pretty easy when you have the calculator in front of you. Like we had a homework question like this: what's the slope around 60,000? You would just look up that last tax rate used and you're good. But when you're working on the homework today, it's going to be more like this, where you just have a picture. So let's remind ourselves how to actually see these rates in the picture. So the marginal tax rates are pretty easy to see because they are the slopes of the corresponding parts you're talking about. So if we're still talking about like 60,000, which would be this point here, it would have a slope of 0.22 because that's the sort of the section that it's in. Now, the average tax rate is a little trickier to see because this line isn't actually on the graph. But what you can do either in your head or you can like hold your finger or pencil up to the screen is if you draw a line from the point that the question gives you. So again, like 60,000, if you draw a line to the origin, the slope of that line is related to the average rate you're considering. Okay, so why is that useful? Well, you're going to have questions like this that are due tonight. They give you a graph and you have to pick one of these four options that's correct. And so I want to show you how you can like eliminate some of these. So this one, the option D is saying the average price for a value of 30,000 is equal to the marginal price at a X value of 30,000. Well, just like I was saying, you can see these are average and marginal numbers by looking at the slopes. This is what I would do if I were you. So in your head, this is not something you actually draw, but in your head, you look at that point on the line that you're considering, so 30,000, and you consider the slope of the actual graph at that point, and you consider the slope if you drew a line through the origin. And then all you have to say to yourself is which line is steeper. Steeper is a higher slope, and that would be the higher number. So in this case, the purple line is the steeper one. The purple line is the one that's actually on this green curve, right? If we were doing this, like it's the slope of that segment. So the purple line represents the marginal price. The blue line represents average. So purple is steeper, purple is bigger. And that's why D would not be the correct option in this particular case. So that is how you can attack these homework questions that ask you to differentiate between average numbers and marginal numbers. And another thing I wanted to point out, just a little tip for the exam, these homework questions like this one, there are different variations where like A, B, C, or D are the correct option. So what I would suggest doing, just for the purpose of reviewing for the test tomorrow, submit a bunch of blank homework so you can see different variations where maybe A is correct or B is correct or C is correct. That way you have more options to prepare with when you're studying for the exam tomorrow. And remember, you can try the homework as much as you want, so it's totally fine to submit a bunch of blank ones. Or if you don't want to do that, you don't want to have 10 different versions of the homework, what you can do is say to yourself, okay, what would the graph look like if A is correct? What would the graph look like if B is correct? You need to be able to know that because, like I said, there will be versions of this either on the homework or the exam where any one of these four could be the correct answer. So you need to know how to distinguish between them. Last question on the homework is kind of weird, so I want to talk about that as well. It basically gives you these two piecewise functions here, and it says, how many times do they intersect? This is a horribly annoying question, which you could do with algebra, but I'm going to show you, in my opinion, the quicker way to do it. Basically, I'm going to figure out how many times they intersect by drawing a graph. So what I'm going to do is essentially write down all the X values that I think could show up in these two ranges they give us. And they say they start at 0 and they go up, somewhere past 20. So I went to like 40. And basically, instead of wasting time with a bunch of if statements, I'm just going to brute force code this. So look at F. F is 100 from 0 to 20. Literally type in 100, drag it to 20. F is 15 times x minus 20 plus 100 for all the numbers after that. So, whoops, I'm going to go into the first number after 20, which is 21. I'm going to do 15 times, do not type x, reference the x, and then plus 100 and drag it down. Likewise, let's do this one for g. G is equal to 3 times x for the first 10. It's equal to 5 times x minus 10 plus 30 for the next 10. And then last of all, it's equal to 80 for all the rest. Okay, make my graph. Oh, look, they don't intersect. Done with the question. So that's how I would do it. You don't need any ifs. You don't need any algebra. It's a little annoying because you have to type in each of these 5 expressions once, but then you're just dragging to get most of it. So it doesn't take too much time if you do it that way.